Good morning. Today's goal is to figure out what does it mean to have an exponent of 0, and are there such things as negative exponents, and what are their values? So to start, as we always do, let's start with what we know and use it to find what we need to know. So let's take a look at these tables and see if we can find any patterns between the exponents that we're already aware of and can easily find the values of. So what I'd like you to do is start by filling out the values that we know. So for example, 2 to the first power would just be 2. 2 to the second power is 2 times 2, so that's 4. Go ahead and fill out all of our values of the ones that we know above the blue line at this time. Press pause and continue when you get that part completed. All right, if you're continuing on in this video, then you should have each of those tables completed, knowing that 2 to the third power is 8, 2 to the fourth power is 16. Let's go ahead and fill in the rest of the tables. So 3, 9, 27, 81, and 243. And if we take a look at our 5s, 5 to the first power is 5, 5 squared is 25, 125, and 625. Now take a look at what we know, and do you recognize any patterns within the data? How can we use what we're being given to help investigate for how we find what 2 to the power of 0 would be? Take a moment and look for patterns in the tables and see if you can use that to help you justify what 2 to the power of 0 might be, what 5 to the power of 0 might be, and what 3 to the power of 0 might be. Again, one more time, look for patterns, look for justifications. Go ahead and pause the video, and when you think you might have something, come back. So as you look down your column of your powers of 2, did you notice that each time we're simply dividing by 2 as the powers of 2 are getting smaller? And folks, if that pattern continues, then it shouldn't change. So folks, what's 2 divided by 2? And we get 1. So could 2 to the power of 0 equal 1? What fits the pattern? So let's take a look at our 5s. If I look down this way, I'm dividing by 5. From 125 to 25, again, dividing by 5. That pattern seems to continue. So if I want to go one less exponent, I'm going to follow that pattern. So 5 divided by 5 is 1. Folks, what do you think 3 to the power of 0 is going to equal? Let's see if we see any patterns there. As we come down this way, now we recognize a pattern of dividing by 3. If we continue that pattern, as we drop by one more exponent, 3 divided by 3 is 1. No matter whether it was 3 to the power of 0, 2 to the power of 0, or 5 to the power of 0, they all equaled 1. So folks, you just found something about the 0 exponent rule, which tells us that no matter what we take to the power of 0, that anything to the power of 0 will always equal 1. Let's go ahead and record that in our notes. So anything to the power of 0 equals 1. It doesn't matter whether it's 1 million to the power of 0, we get 1. Negative 46 to the power of 0, we get 1. Well, now let's keep investigating, and let's take a look into these negative exponents. So as we go down each table, we should notice that the values are getting smaller each time because we're showing some repeated division. Well, that doesn't change as we keep going down. What most people believe is when you see a negative exponent, everybody immediately wants to go down to a negative value. Well, folks, if the base is positive, you're going to end up with a positive answer, not something that's negative. But if we continue that pattern, let's look at what happens. If I take 1 divided by 2, I get 1/2. If I continue that pattern again, 1/2 divided by 2 is 1/4. If I can continue that pattern again, 1/4 divided by 2 is 1/8. Now, let's look at that whole table of our powers of 2. Take a moment. Do you notice anything? Go ahead and pause the video. So maybe you've recognized something, maybe not yet. Let's take a look at our 5s. If we continue our pattern here, and we're dividing by 5, 1 divided by 5 is 1/5. Continuing along would be 1/25. Dividing by 5 again would be 1/125. So again, now that we have 2 tables set, do you notice any patterns now? Take a moment to pause and take a look. Has anybody noticed that the negative exponents are just the reciprocal of the positive exponents? If I take a look at my 2's, this is the same as saying 1 over 2 to the first, 1 over 2 to the second, and 1 over 2 to the third. All I did was take my table from above and basically took the reciprocal below. As I take a look at my 5's, this is 1 over 5 to the first power, 1 over 5 to the second power, and 1 over 5 to the third power. Having seen that pattern, what do you think 3 to the negative first power and 3 to the negative second power will be? Jot down your prediction. Let's see if you were right. Did you guess 1 over 3 to the first power, which would be 1/3? 1 over 3 to the second power, which would be 1/9? We just discovered the values of negative exponents in the negative exponent rule. Let's fill that in together. So taking a negative exponent does not make the base negative. It's just going to take that value and it's going to make it smaller because it's showing repeated division instead of multiplication. So when we have a power such as x to the negative first, we're simply going to take the reciprocal and then the exponent becomes positive. If the negative exponent is in the denominator, the reciprocal would be to bring it to the numerator and the exponent becomes positive. So the law of negative exponents is to take the reciprocal and the exponents becomes positive. All right, go ahead and pause the video and let's try those practice problems at the bottom. Let's see how we did. 7 to the power of 0 is 1 because anything to the power of 0 is 1. 7 to the negative second power, if I have a negative exponent, I'm going to take the reciprocal and make the exponent positive. So I get 1 over 7 to the second power. Number 3, I have the quantity of x, y, z to the power of 0. Remember, it doesn't matter what we raise to the power of 0. We always get 1. 5 to the negative fourth power. The reciprocal would be 1 over 5 to the fourth. The exponent then becomes positive. 1 over 3 to the negative second. To make that exponent positive, we take the reciprocal. So since it's in the denominator, it comes to the numerator. And then anything over 1 is itself. We get 3 squared. 1,000 to the power of 0. Anything to the power of 0 is 1. 1 over 6 to the negative third. Our reciprocal would be 6 to the third over 1, which reduces to 6 to the third. Take that reciprocal and make that exponent positive. 25 to the power of 0. You got it. That's 1. Anything to the power of 0 is 1. And last but not least, 10 to the negative fourth power would be 1 over 10 to the fourth. So how'd you do? Let's see if you've got the hang on it. Let's practice some IXL.